Okay, welcome back. We're continuing with our inverse functions, and in the next couple examples, kind of already addressed in the previous video, but let's just hit them real fast. So the horizontal line test is testing whether the inverse relation is a function. So we're actually thinking about the reflection, and we're doing a vertical line test, but we're doing it horizontally because we're going to reflect this thing. So this definitely violates the horizontal line test. So it is not one-to-one. So one-to-one functions pass the horizontal line test. Now here's an example of one that does. It's a little subtle because it's so flat, but every time you run a horizontal line through this thing, it just hits 1. And so this actually is a one-to-one function. It passes the horizontal line test, although a little bit subtle there. All right, let's do a hard one now. Number 8. So there's a couple things they want us to do here. They want us to graph it, use our calculator to find the graph of the inverse, and then a few other things about the domain. And anyway, so let's do this. So first of all, our function is the square root of x plus 3. So let's get that in our calculator, and let's get it on a standard screen. All right, so here we go. We've got the square root of x plus 3, and we're going to go with a standard window for this. All right, we might have to zoom if we want to, but there it is. There's the square root of x plus 3. All right, now to find the inverse, we want to reflect it. I'm going to do two things. One, I'm going to put the line y equals x in here. And there we go. The other thing I want to do, it's going to make things look a little bit better, is square the window up. Now, the squaring of the window just takes a little bit of that aspect ratio stretch out of this. It makes the x-axis units the same distance as the y-axis. It also gives us a clean 45-degree angle there. So remember, this is our function, square root of x plus 3, and this is the line y equals x that we're about to reflect about. Okay, now how do you reflect? Well, you go to the draw menu. The draw menu is second function of PRGM, and we actually want to scroll down until you see draw inverse. There it is. Draw inverse. Now, your calculator might be different. It might pull up a menu, but mine just says draw inverse, and then you tell it which y function to draw the inverse for. Now, again, you're going to have to find these menus, so listen carefully. To find the y1, we go under vars, and then we move over to y-vars, function y1. And so draw inverse of y1, and hit enter, and there it is. We just drew the inverse function. So we don't even know what the formula is at this point, but we have a nice picture of it, and we can answer a lot of questions about it just by looking at the picture. All right, let me zoom this out a bit. Okay, so we can see a little bit better. All right, so remember, this is our function. This is the square root of x plus 3, and then this is the inverse function right here. All right, and then this is the line y equals x that we were reflecting about. This is where the mirror is located. Okay, so let's. I guess we should pick out the right picture first, and then proceed to talk about domain and range. I told you it's kind of an involved one. So first of all, looking at the pictures, this one is out. That one's a little messed up. It's got an extra piece there. This doesn't exist. The answer is clearly D. All right, so we got the first part done. Now it says, what's the domain and range of f are not all real numbers. The domain of f is. Now, so concentrate on the blue function for a second. The blue function starts here and it goes that way. It is not defined out here. So this stuff is not in the domain. So the domain actually starts here and it goes that way for the blue function. Now, what is that point exactly? Well, if you pull out your calculator and hit trace, you can see that that's a -3. See, right after we went past -3, it became undefined. At -3, it's exactly 0. So -3 is where this domain begins, and it goes all the way to positive infinity. Now, the range, okay, again, you gotta look at it carefully. The range are the outputs. And so let me do it in green. The output. So if you kind of think about horizontal line tests, it actually will help you. So concentrate on the blue function though. Now the blue function doesn't have any y values that are negative, but it does. But it is equal to 0, and it goes like that. So the range are the outputs, the y values. And there aren't any. So there's no negative y values for f. Okay, so the range starts at 0 and goes to positive infinity. Now that's actually a lot of information. We can know exactly the domain and range of the inverse function if we already know those two. And so it is going to be easier from here on out. So it says, what is the domain of f inverse? Well, they switch places. So let me say the domain of f. Let me write it like that. So it's -3 to infinity. The range of f is 0 to infinity. The domain of f inverse and the range of f inverse are they just swap because they're a reflection. You can even see it on here. The x values become the y values, and the y values become the x values. So this other function, let's turn on the red. The red function has a domain that includes 0. In fact, it's a bracket, so it starts at 0 and it goes to infinity. It's actually that over there. The range of f became the domain of f inverse. And similarly, the range of f inverse, if you think about what are all the possibilities for the range of f inverse, well, it actually starts here and goes all the way up. So it actually begins at -3 and it goes to positive infinity. It's just this one. The domain of f is the range of f inverse. So I'm just putting that down here. The domain of f inverse is 0 to 0 to infinity, and the range is -3 to infinity. They just swap places. Anyway, I'm going to end the video there. I don't want to go too long. Talk to you in a minute.